Good afternoon, everyone. Today I'm representing Work Package 5 and Toulouse Gavier-Vidin, who unfortunately could not be with us today. And I come from the Swedish National Veterinary Institute in Uppsala, work at the Department of Pathology and Wildlife Diseases, and I'm going to talk a little bit about the deliverable pathology on selected cases. So why pathology? We love pathology. It's a wonderful tool in wildlife surveillance for giving a comprehensive and broad picture of a case. And if we look at this tiny little hair, it gives us quite a lot of information. I hope you can see that it's emaciated, there are no fat reserves, its tissues are very pale, it's dirty in the back. If we look close up, you see the ventricle, and you see the enlarged spleen, dark red with multiple white dots. You see the dilated large intestine with a watery content. And this tells us that this hare probably suffered from a generalized bacterial infection and an enteritis. And in this case, tularemia could be a good guess if it's from the right geographical area. It could also be a number of other bacteria behind this. Pathology can also help us in designing sampling protocols for wildlife disease surveillance. And primarily, pathology is broad and it keeps us ready, makes us ready and prepared for the unexpected diseases. So for the pathology on selected cases, we've focused on tularemia, and that is because tularemia is an important wildlife disease. It's an emerging zoonotic infection. It's present in most of Europe, and I need my little assistance here. It's vector-borne, and it's transmitted through direct contact, through inhalation to ingestion. It is a well-studied disease, but there's quite a lot still not known about it. And the cause, as you all know, is a gram-negative bacterium, Francisella tularensis, that appears in several subspecies of varying virulence. Tularemia is widely distributed across the northern hemisphere with extreme hotspots and in other areas considered an emerging disease. Its epidemiology is characterized by outbreaks, and it mainly affects hares and rodents, causing acute septicemic disease with occasional spillover to humans and rabbits and domestic animals. Out of the 38 European member states or potential member states, 31 report human cases of tularemia, and Sweden accounts for almost a quarter of those. And last year we had about 590 cases due to a large outbreak in the northernmost part of the country in hares and humans. The general picture of tularemia is that it causes an acute septicemic disease in hares and rodents. But in Central Europe, there are also subacute and chronic cases, as illustrated by the chronic inflammation in a kidney from a hare from Hungary. And in Central Europe, hares are thought to be the reservoir of tularemia in between outbreaks. But in Scandinavia, only the acute septicemic form has been described, and we don't know what the reservoir is. There could be chronic carriers amongst hares, and we also know from experimental studies that Francisella bacteria can survive in amoebas in freshwater sediments, for instance. The typical picture is what you see here, the enlarged, blood-filled, extended organs like the liver, spleen, and bone marrow, with multiple pale necrotic foci. But in many cases, the gross lesions are difficult to see or very inconspicuous. In the microscopically, the clinical picture is always there. The multiple small areas of necrosis in multiple organs, as you see in this liver. And close-up shows an area of necrosis. It's the same liver as before. You see there's no inflammation around the area. There is some hyperemia, even some hemorrhage. And using immunohistochemistry, we can see the bacteria, large amounts of bacteria, in the necrotic area. The work that's been done within the WildTech project, looking at hares in more detail, has shown that also in Swedish hares there exist subacute changes. About 10% of the hares that are infected and examined have subacute changes in certain organs, and that is mainly the kidneys and the meninges of the brain. And here you see the cerebral cortex and a quite conspicuous inflammation, mixed inflammation in the pachymeninges and around the vessel. Pathology can also help us explain means of dissemination of bacteria and ways of infection. And if you look at up to the far left, you see a section of a kidney. You see the renal pelvis up there, and the renal medulla, and there's necrosis and quite a lot of inflammation and lots of bacteria, and there are also bacteria out in the pelvic region, suggesting dissemination of bacteria through the via the urine. If you look at the lung, we have areas of acute necrosis, lots of bacteria, but you also have bacteria in the epithelium lining the bronchioli. And you also have bacteria in the cells, in the epithelial cells being shed, suggesting dissemination of bacteria through bronchiolar secretion. The third picture is, these are all from hares that have died in tularemia. There's a bite skin, and you see the bite wound of a tick. The tick itself has fallen off in the preparation of the specimen, but around the wound you can see these enormous amounts, the aggregated Francisella bacteria from the tick infecting the hare. So, in summary, we can say that the classical picture of an acute disease is true, but we also have the subacute changes in certain organs in about 10% of the hares. The gross lesions are not always to be trusted when you do a necropsy, and we have not found any chronic lesions so far. But to further investigate the possibility of chronic carriers, we have started serologic testing of hares collecting during hunting in 3 endemic areas in Sweden. So, how did I match the time? Thanks.